In sketching of exponential and logarithmic graphs or functions, the most important thing to take note of are firstly the asymptotes, and the x-intercepts, and the y-intercepts. First, we'll look at exponential functions. So in exponential functions, the basic function is e to the power x. In e to the power x, if we need to take out the y-intercept, at the y-intercept, x is 0. So e to the power 0 is equals to 1. So the y-intercept is 1. Now for the asymptote, we have to learn that exponential functions have a horizontal asymptote and logarithmic functions have a vertical asymptote. What are asymptotes? Asymptotes are lines that meet a curve at infinity. For example, if we have a function like this, or in fact, if we have the tan graph, in the tan graph, it starts at 0, tan x. Here the point is 45,1, and then it meets the line at 90 at infinity. So over here, x equals to 90. This is the line x equals to 90 degrees. This is the vertical asymptote. So to find the vertical asymptote, that is the point, that is the line at which the curve is undefined. So when will an exponential curve be undefined? When an exponent is equals to 0, when anything to the power, when anything with a power is equal to 0, it is undefined. Because to solve this, what we would do is we would write ln e to the power x equals to ln 0. So x equals to ln 0, and ln 0 is undefined. So that means that at y equals to 0, e to the power x is undefined. So the vertical asymptote is y equals to 0. So we've got two things. The first one was the y-intercept, which was 0, 1. So for example, this point is 0, 1. And y equals to 0, which is the x-axis, is the horizontal asymptote. This is the horizontal asymptote. Now to find which part will be increased, which part will be like, see the general shape of this curve will be in this manner. And how can we determine that this is the shape? If, for example, we take certain values, e to the power, for example, -1, it will be equals to 1 upon e. And e to the power 1 is equals to e. Over here, e is greater than 1 upon e. So that means that when it is 1, when the value is 1, the graph, the value of the graph, the value of the function should be more than when the x value is -1. So that's why it is an increasing function. Now, if, for example, we have the graph of e to the power 2x. So over here, there won't be any change in the sketching of the graph, but if we were drawing the graph accurately on a graph paper, then there would be a difference in the points. But again, over here, if we write e to the power 2 times 0, that is to find the y-intercept, x is 0. So again, this will be e to the power 0 equals to 1. So y-intercept stays the same. And if we write e to the power 2x equals to 0, so again, ln, we'll get ln 0 and x. So that's why the horizontal asymptote will be the x-axis again. So this will also be the general shape of a graph that is e to the power 2x. Now, if the graph was for 3 times e to the power 2x, once again, the general shape of the curve would be the same in sketching, but in drawing, if we had to draw, then it would be different. But in our syllabus, it's only sketching. So this will be the shape again, because over here, in fact, there'll be one change, that is in the y-intercept, because if we have 3 e to the power 2 times 0 in place of x, we'll get the value 3. So the shape will be same, but the y-intercept will change to 3. And again, the horizontal asymptote will stay at the x-axis, because if we had 3 e to the power 2x equals to 0, then we would have e to the power 2x equals to 0, and again ln 0, which would be undefined. So that's why x-axis is the horizontal asymptote. Now the next one is 3 e to the power 2x plus 1. Now what does the plus 1 represent? The plus 1 represents that the whole graph, every value of the function is being shifted upwards by 1 unit. So 3 will be shifted upwards to 4 by 1 unit. And this horizontal asymptote, wait, I'll draw this graph again. So this is for 3 e to the power 2x. And now I'm drawing 3 e to the power 2x plus 1 in red. So every point will be shifted 1 unit upwards. 3 will be shifted to 4. And the horizontal asymptote from y equals to 0 will be shifted to y equals to 1. So now this will be the horizontal asymptote. Therefore, this will be the shape, the sketch of 3 e to the power 2x plus 1. Now, if, for example, we had to draw negative 3 e to the power x. Now, what does negative represent? Negative represents that every value in, for example, in the third function, that is 3 e to the power 2x, we were getting all positive values, but over here we'll be getting all negative values. So the graph will be similar to 3 e to the power 2x, but a reflection of that in the x-axis. So for example, for our y-intercept, we will take minus 3 e to the power 2 times 0. So this is coming as minus 3. And the horizontal asymptote again will be the x-axis. So this is, for example, minus 3. So this will be the curve. There's one more type of exponential curve, that is if the power was negative. So for example, if we had e to the power minus x, so over here, what would happen is the y-intercept would still be 1, the horizontal asymptote would still be 0. However, now it will be a decreasing function because the gradient will be negative. If you find dy over dx would be negative e to the power minus x. So gradient is negative. So that's why the shape will be a decreasing function. Next are graphs of ln, natural log. First, we'll take ln x. So in ln, in graphs of natural log, we have a vertical asymptote and we have x-intercepts. So first, how to find the x-intercept? At the x-intercept, the value of y is 0. So for example, if this is our function, then y will be 0. So to find the value of x, we'll shift ln to the left side, it will become e to the power 0, which is equals to 1. So the x-intercept is 1, for example, over here. Now, how to find the vertical asymptote? In any log, if the multiple is 0, then it is undefined. So when is the multiple in ln x equals to 0? That is when x is 0. So that means that at x equals to 0, there is an asymptote, and that will be the y-axis, a vertical asymptote. So this is our asymptote, this is our intercept. Now, how to determine that will our function be increasing or decreasing? Over here, you can simply find the gradient, that is dy over dx, that will be 1 upon x, that is positive, so it should be an increasing function. So you can directly sketch it in this way, or you could take 2 points, like 1 point before 1 point after 1. So 0 point, you could take 0.5, ln 0.5 is equals to negative 0.7. So that means that below the x-axis. And then if you take 1.5, that is 0.4. So that means above the x-axis. So this is the shape for ln x. Now, if we had ln 2x plus 3, so to find the x-intercept, again, y will be 0. So ln 2x plus 3 will be equals to 0. So 2x plus 3 equals to e to the power 0, which is 1. So x will be equals to 1 minus 3 is minus 2. Minus 2 upon 2 is minus 1. So negative 1 is the x-intercept. Now to find the vertical asymptote, again, to add the vertical asymptote, the multiple of the log has to be 0. So x is equals to negative 3 upon 2. That is negative 1.5. So if this is negative 2, this will be the vertical asymptote. Over here, again, to find the shape of the curve, you can find dy over dx. Dy over dx will be, the first derivative would be 2 upon 2x plus 3. So this is positive, that means it's an increasing function. So this would be the shape, or you could take one value before negative 1, one value after negative 1. The value before negative 1, like negative 1.25. If we take negative 1.25, ln 2 times negative 1.25 plus 3, this is equals to negative 0.7. So that means below the x-axis before negative 1. And if we take negative 0.25, that is 0.9 above the x-axis. So after negative 1, it's above the x-axis. And over here, as it is cutting the y-axis, you can also find the y-intercept. To find the y-intercept, x is 0. So ln 2 times 0 is 0. So ln 3 is the y-intercept. Over here, we can write ln 3. Now, one more thing to note is that graphs of exponential functions and graphs of logarithmic functions are inverses of each other. So for example, this is the general graph of e to the power x, and this is the general graph of e to the power, sorry, ln x. This is the general graph of ln x. So these are inverses of each other. That means that they are reflections of each other in the line y equals to x. This is sketching, so it's a bit rough. So this property is very important in the past papers. This point is 1, because usually what happens is that we have to draw the graph of one of these, either an exponential function or a logarithmic function, and then you have to draw the graph of its inverse. So you can just draw the graph of one of them and then reflect it in the line y equals to x. So for example, if we had a question that fx equals to e to the power x minus 2, and we have to sketch fx, and hence sketch f inverse x. So we'll draw the axes. Now for the exponential graph e to the power x minus 2, first we'll find the y-intercept. For the y-intercept, x is 0. So the y-intercept is 1 minus 2, that is minus 1. And the horizontal asymptote, at the horizontal asymptote, e to the power x has to be 0. So when is e to the power x equals to 0? If e to the power x minus 2 was equals to minus 2, then minus 2 and minus 2 would get cancelled, and e to the power x would be equals to 0. Then x would become undefined over here. So at y equals to minus 2, we have the horizontal asymptote. We found minus 1 as the y-intercept and minus 2 as the horizontal asymptote. This is minus 1. This is minus 2. Our graph was e to the power x minus 2. So if you find the first derivative, that would be 1 upon x. So that is positive, so an increasing function. So the function would be somewhat like this. Now over here we have an x-intercept. To find the x-intercept, the function should be equals to 0. So e to the power x minus 2 equals to 0. That is ln2. If you solve that, you'll get ln2. So this point is ln2. Another way of drawing this graph would be that you first draw e to the power x. This is 1, and then you just shift it downwards by 2 units because it's minus 2. Now, the next part of the question said that we have to hence sketch f inverse x. Now, one way of doing this could be that you find the inverse of fx. That would be ln x minus 2, I guess, x plus 2. Yeah, it would be ln x plus 2. and then you could sketch the graph of that. Or because over here it said hence, that means that we have to use the first part to solve the second part. So we could directly find the inverse of this graph. So for the inverse, we'll first draw the line y equals to x. So this is the line y equals to x, and now we'll reflect the graph. So first we'll reflect the asymptote. The horizontal asymptote will become a vertical asymptote at -2. The y-intercept will become an x-intercept at -1. And x-intercept will become a y-intercept at ln 2. So this will be the shape of f inverse x. And this was fx.